Hi, boys and girls. It's Miss Bissell. I am going to go over your math test that you took yesterday. This was a SchoolNet math test, so as we know, it was digital, but you were to have graph paper out. You were allowed to use a calculator since I have not taught you how to multiply and divide by two-digit numbers. And I'm also just trying to assess your knowledge of volume concepts, so it's okay if you had some help with the calculator on this. I think the biggest problems that I saw were with the children that are not completing their assignments daily. Every day that your math is assigned, you should complete that assignment before you go to bed, just like you would treat traditional school. The next day, you should take care of your math assignment because it builds on what we did the prior day. And it works like that throughout each chapter. The last lessons, sometimes the last two lessons of the chapter, are the hardest lessons because we're taking the concepts that we've learned early in the chapter, which are usually learning or lower level thinking skills, and we're now using those concepts in new scenarios. So we're applying them to usually real world situations. In this case, real world scenarios when you would use volume. So those problems are even harder because they're hitting those higher level application skills, analyzing skills. So the children that did their work religiously and they stayed on top of their assignments Monday, Tuesday, Wednesday, Thursday, and so on, were able to do a whole lot better with their math tests than those that did not. And I was really concerned because I made a quizzes assignment yesterday for students to review, and I tried to make sure that I had one concept like every item that was going to show up on the test today just to give them practice with it. And it was shocking to me that out of our 60, I think 4 students, I think 54 of them completed the assignment. So a lot of children came in to take their assignment today and had not reviewed for it. So, you have your math journal, which had pages 33 to 40, which had review materials in it. And then, of course, you had, your homework assignments. And the quizzes would have been the most valuable one because that was your review of all the concepts. So with that being said, I'm going to jump in, kind of talk about the concepts and some things that I saw. We've got to always start our problems with the formula. Even though you can count cubes, here Sam's making a rectangular prism from unit cubes, and we want to know how many cubes does he need. I get that from our first lesson we learned how to count them, but from our second lesson we learned how to use the formula. And if we use the formula in conjunction with counting them, then we're going to be more likely to get the problem correct. So let's talk about that. I can eyeball it visually and see that there are 4 cubes on the top layer. I just colored the top of the cubes and the front and the side. And I have 1, 2, 3, 4, 5, 6, 7 layers. So guessing, I think I have 28 layers, right? 28 cubes. So let's use the formula. Length times width times height. I can see very clearly, and we always write the formula, then we plug in the values for the known measurements. It's 2 units long, 2 units wide, 6 units tall. 7. So, plugged in my values, 2 for length, 2 for width, 7 for height. I multiplied the first 2, so I put parentheses around it so you could see that's what I did. 4, bring down the times 7. 4 times 7 is 28 cubes needed. And when I do that, I can very clearly see that I got that problem correct. I counted it, and then I checked it with my formula. Nothing tricky on that problem. Number 2, Victoria made a rectangular prism by connecting cubes as shown below. How many cubes did she use? Guys, this is very much like the previous problem. So once again, yes, we could count them. We could count how many are on the top and then how many layers there are. To me, I think it's easier to write the formula, plug in the values. 1, 2, 3, 4, 5 units long. 1, 2, 3, 4 units front to back, so width. 1, 2, 3 units high. I've written the formula. I'm going to multiply 5 times 4 to get 20. Bring down the times 3. I have 60 cubes. To check it, I could look 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There are 20 cubes on that top layer. There are 3 layers. 20 times 3 is 60. So I just verified it. Number 3, if you didn't read question carefully, I highlighted what the trick was, then you missed this problem. And I did intentionally put a problem just like this on the quizzes assignment for the review. I think it said that Ms. Pacell removed the top layer of blocks. Anyways, if Isabella removes the top layer of blocks, what will the volume be of the volume of the resulting figure? Sorry about that. So I know that if I'm removing something, that I'm subtracting it. So I must subtract the number of cubes on the top layer. Or some of you might have pretended it was never there and never included it in your counting of the cubes or your volume formula. So I worked it both ways for you. So let's use the whole thing. The volume formula that we would use would be the length, width, and height, 3 units long, 2 units wide, 1, 2, 3, 4, 5, 6 units high. Here we go. I'm going to multiply the 3 times 2 first. That is why I put parentheses around it, so you can see that's what I did, and that's where I get 6 times 6 is 36. But wait a minute. I colored the 6 cubes on the top that I'm going to remove. I have 30 cubic units left. Now, if you wanted to remove them to start with visually and pretend they never existed, then your length, width, and height would change just a little bit. Your length would still be 3 units. Your width would remain 2, but if you took off the top layer, you don't have 6 cubes high, you have 5. Then you multiply 3 times 2 is 6, 6 times 5 is 30. So whichever method you wanted to use, the answer was 30 cubic units. Number 4, the product of 5 times 4 times 3 represents the volume of a rectangular prism. Which prism best models this product? Each small cube is 1 unit on each side. And I said a tip here. I put it in here. Make sure you carefully analyze the dimensions of each prism before selecting your answer. And if you do that, what you will realize is there's not one that you have to make a determination on that would be the best model. There's only one that is an accurate model, meaning there is only one of these that has the 3 dimensions that have 5, 4, and 3. And it happens to be the first one. When I count it, 1, 2, 3, 4, 5 units, 1, 2, 3, 4 units, that's the length and the width, and the height is 3. I'm going to still check the other ones because I maybe do have to make a determination on which one best matches 5 times 4 times 3. When I get to B, I notice that can't be. It is 5 units long. That's okay. But it's 3 units wide, and it's got to be 4. So right there's the problem with this one. So I don't even want to consider B. Let's look at C. 4 units. Oh, wait a minute. There's the problem. But I'll go ahead and check the other. Maybe they use the commutative property or associative property of multiplication and move these cubes out of order, the factors. 1, 2, 3, 4. Nope, I've got to have a 5, a 4, and a 3. So this can't be it. The 3 dimensions don't match 5, 4, and 3. Same problem here. 4 long, 3 wide, 3 high. You know what? I need to have a 5, a 4, and a 3, so I'm missing a 5. So it can only be Model A. Model A is the only one that has 5, 4, and 3 as the dimensions. Now, of course, you could have worked this to see the total number of cubic units. And 5 times 4 is 20, 20 times 3 is 60, so 60 cubic units. Then you could have worked each of these, but the only one that's going to come up with 60 cubic units as its volume is A, because it's the only one that has the same 3 dimensions. The other ones are just off by 1. All right, number 5. The dimensions of a rectangular prism are modeled below. Which equation shows one way to find the volume in cubic feet of this rectangular prism? So when I first read this, I thought maybe they're going to try to trick me, and maybe they're going to call the length the width and the length, we talked about that. It's not really going to matter because when you have three factors that you're multiplying together, it doesn't matter what order we multiply them in, nor does it matter which ones we multiply together first. We can use either the commutative property of multiplication and change the order of some add-ins, or we can use the associative property of communication and change the order in which we multiply things first by moving parentheses around. So I looked at this one first, and I just went ahead and figured out that the length is 8 long. The width is 2, front to back, the width 2. Sometimes we call that the depth. The height is 3. And it just so happened that only, 2 of these have those same dimensions, A and C. But the problem with A is you're not multiplying the 3 dimensions. The multiplication is what builds the base and then what builds the height. That's what gives us the 3 dimension. Here you're just adding it. That would be like perimeter, where you're just getting linear units, okay? So if you thought of it that way, then you could quickly eliminate and come to C pretty quick. Now, another thing that you could do is you could work this and see how many cubic units you have, and you have 48, and the only one that matches is C, okay? Some people will work a problem. There's a couple of different strategies here, but the bottom line is you've got to have 3 dimensions, 8, 3, and 2, whatever order, and they each have to be multiplied together. Number 8, Coach Nelson is adding water to a swimming pool. Which units should be used to describe the volume of water Coach Nelson needs to fill the swimming pool? Volume is the number of cubic units. So here's a huge cube. I don't have my small centimeter one, but here's a huge cube. So how many of these fill up the swimming pool? All right, and I don't know what units we're using. I would think it's probably meters, something large, yards possibly. All right, but look at this. Cubic units means cubes. You're filling it up with cubes. You're using 3 dimensions. Isn't that what volume is all about? That is, to me, the answer. Linear units are a straight line. So we would use a ruler to get a linear measurement. So think about perimeter. You would use a ruler. You'd measure each of the 4 sides and add it together of a picture frame if you wanted to put something around it like a frame. Square units. Those are the squares that fill up a 2D figure, like maybe you are carpeting your rectangular shaped bedroom. All right, how many square units fill up your room without any gaps or overlays? So that's what you worked on last year when you worked with area. And rectangular units, never even heard of that. I don't know what you fill up with rectangular units, so that's kind of just a silly answer. So volume is associated with cubic units, and those cubes represent the length, the width, and the height, right? We talked about that. All right, number 7. Emily built the sandbox for her younger sister. What is the volume? Guys, it is just amazing to me the number of people that will take the time and write the formula, plug in the values, and they get it right every single time. And then there's those of you that want to shortcut it and you don't want to write the volume formula. You want to try to multiply 3 add-ins at one time. You just want to go against everything that Miss Bassel's taught you in the lessons and just have sloppy, unorganized work. And then you could be the best math student, but you make the silliest, careless mistakes. And then your potential doesn't show when you're testing. It's not test anxiety. It's just that you're not giving your best. You're trying to shortcut it. Don't do that. You will do so much better in math if you will use the strategies that your teachers teach you. So I taught you, and I'm very adamant about it, whether you're doing homework or a benchmark test or an end of grade test or just a spiral review, those weekly review sheets. I want to see that volume formula written. It's one of two. You're either doing volume equals length times width times height, or you're doing volume equals base times height. When you're working with area from 4th grade, I want to see area equals length times width. And then I want to see those values filled in, and I want to see you working one step at a time. I've made that very clear in class, and the children that are following my directions are amazing me. I have some kids that struggled with math last year that are just killing it this year with great grades because they're listening. And then I have some that want to go rogue and do their own thing. So It's early in the year. Let's, try things the way your teachers are teaching you them. All right, so the length on this sandbox is 6. The width is 4. The height is 2. I picked 4 and 2 to multiply together. I get 8. 6 times 8 is 48. 48 cubic feet in the sandbox is the volume. Number 8, what's the volume of the rectangular box that measures 3 by 8 by 20? Guys, that's just your dimensions. It doesn't matter what you call the length, width, or height when it's all said and done. I just used 3 times 8 times 20, started with 3 times 8 is 20. I know that, did I say 3 times 8 is 20? Sorry, 3 times 8 times 20. I know 3 times 8 is 24, 24 times 20. I did a little bit of math in my head. 24 times 10 is 240, so 24 times 20 would double that to 480. You guys had a calculator, no problem. 480 cubic inches. The answer would have been B. A lot of you jumped on A, and this was your problem. It needs to be cubic inches, not square inches. That was a trick me one. Be careful. Number 9, a shoebox is 15 inches long, 9 inches wide, and 5 inches tall. What is the volume? Again, write your formula, plug in your values. I'm a bad girl. I didn't write my formula. There it is. Plugged in the values. I chose to multiply 9 times 5, 15 times 45. You guys had a calculator. I did 45 times 5, kind of broke it up, and knew that 45 times 5 was 225. I know 10 times 45 is 450. I just added it together. I just decomposed a little bit. I didn't have a calculator anywhere near me when I was working on this key. So you folks had a key or had a calculator right in front of you, so that wouldn't have been an issue. Your answer, 675 cubic inches, is D. Number 10, an ice chest is 2 feet wide, 2 feet tall, and 2 feet long. Which of the following represents the volume? Guys, it's very basic. Write your formula, plug in the values, pick 2 factors to multiply, then multiply it times the third one, 8 cubic feet, answer C. I know I'm going fast. You're welcome to pause it and rewind and look at any again. Hopefully you are looking at your work from yesterday's test. You should have had your graph paper with it labeled. Number 11, which right rectangular prism has the same volume as the prism before? These are all right rectangular prisms, so that's not the issue. The issue is we've got to find one with the same volume. So my thought, maybe in the only strategy, my thought is let's find the volume of this prism. 60 cubic meters, 5 meters long, 4 meters wide, 3 meters high. Wrote the volume formula, plugged in the values, did the math, got 60 cubic meters. So I need to find one of these that have the same 3 dimensions, or that's not happening. So when I multiply these together, the volume needs to be 60 meters, 60 cubic meters. The only one that it works for is D. I got panicked when I got through C and didn't have the answer yet, but it was definitely D. I just plugged in the length, width, and height. This one 10 times 4 times 3. This one 7 times 2 times 4. This one 8 times 1 times 5. This one 10 times 3 times 2. The answer was D. Number 12, the volume of the prism shown below is 135 cubic inches. Whoa, they just gave me the volume. What is the value of H? There it is. What is the value of the height? This is that missing unknown edge that I need to find. So I know the volume. I know the length. I know the width. I don't know the height. All right. I'm going to set up the formula and plug in the values that I do know. The volume is 135. The length is 9 inches. The width is 3. I don't know the height. 9 times 3 is 27. When I get to this step right here, I just use those fact families. You know how we've been working with those fact families on our weekly reviews? This is why. If you recognize that this is part of a fact family where you're multiplying 27 times another factor to get 135, then to find the unknown factor, you just divide the product by the known factor. So you take your 135, divide it by 27, it equals the height. When you use your calculator, you got 5 inches. Your height is 5 inches A. A good way to check this one is just very simply take your length times your width. Whoops, give me a second. There we go. Take your length times your width times the height that you think you found. All right. 9 times 3 is 27. 27 times 5. 5 times 7 is 35. 5 times 2 is 10 plus 3. I get 135. So right here, I get 135 cubic inches. So you can always check your work too. You guys had calculators. That would have taken all of 30 seconds. Number 13, George's swimming pool is shaped like a rectangular prism. The bottom of the pool, the base, has an area of 200 square feet. The depth, the height of the pool is 5 feet. What is the volume of George's swimming pool in cubic feet? There it is. The one so far that you need to use, volume equals base times height. You recognized that you have the base square unit. Somebody's already multiplied the length and width for us. So we are just going to multiply the base of 200 times the height of 5 feet. Real quick mental math. You guys know, I've been doing this on the weekly reviews too. 2 times 5 is 10. And then we have these 2 zeros that are in one of the factors that we haven't multiplied yet. We annex those to the 10, the product of 2 and 5, to get 1,000 cubic feet. Again, y'all had a calculator. That shouldn't have been an issue. Your answer, 1,000 cubic feet, is C. Number 14, here's your solid. The diagram shows the dimensions in centimeters of 2 rectangular prisms joined together. What is the combined volume of these prisms in cubic centimeters? My tip was to sketch the prisms on your paper to find the combined volume. So I'm not needing to sketch it because I did print out the test. You probably needed to sketch it. Prism A, Prism B started with the formula. Prism A to the left is the one I'm calling A. I'm looking for the length, width, and height. The length, width, and height. If I know the concepts around rectangles, I know that opposite sides have the same length. So I know that on rectangular prisms, opposite edges have the same length, and that is what is going to help me. We talked in my video and we talked in my class on the day that we did this lesson that we have to be a little bit of a geometry kind of detective. So here we go. This would be the length right here. This 4 to me isn't the whole thing. If it was, it would be more centered. And the other thing is, if I look at this line and this line, I notice they're equivalent in length. So these are 4 centimeters, and that's not all the way across. So that's not helping me. An opposite edge that could help me would be this one, but there's no label. An opposite edge to this one, they run parallel, they're opposite, is this one. 2 centimeters is going to be the length of Prism A. The width, front to back. Oh, this one would be a width. This one would be a width edge. They're opposite. They're not labeled. Opposite of this one is this edge. And I notice centered right there, nice and neat, 3 centimeters. That is the width. The height is top to bottom. This is the taller of the two, and that would be this edge or its opposite edge or its opposite edge, which would be this one. And centered right in the middle is 8 centimeters. So that's the height. So when I plugged in those values for Prism A for the length, width, and height, multiplied the length and width to get 6 times the height of 8, Prism A has 48 cubic centimeters. Now it's time to work on Prism B. When I look at Prism B, the length of it I saw a minute ago. Remember, we talked about these two being equivalent looking. This would be the length, 4 centimeters. The width would be front to back. So the only edge that I see, because I can't see this one, is this. I don't see this one or that one either. But it's nicely labeled in the middle. And you know what? These two prisms actually have the same width, don't they? They're both 3 centimeters wide. The height, right here, clearly labeled 4 centimeters. So when I plug in my values and I went ahead and multiplied the width times the height. So I have 4 times 12, 48 cubic centimeters. Then I combine the volume to get the volume of the entire solid. 48 plus 48, 96 cubic centimeters. Your answer is C. And the last problem on the test, number 15. 2 rectangular prisms are sitting on top of each other. What is the combined volume in cubic units of the rectangular prisms? Tip, sketch the prisms on your paper to find the combined volume. So I walked around the room. I saw a lot of you following directions. Some of you chose not to. You probably were the ones that missed this one. So I'm going to call the prism on top A, the prism on the bottom B. A, when I look at it, prism A, this here to this here would be my length right here. I don't see it labeled. This would be an opposite edge, but it's not labeled. This would be an opposite edge, 5 inches. So for prism A, I'm going to go with 5 inches for the length. The width, front to back, I clearly see that prism A and B are the same length front to back. This edge and this edge are parallel. Neither one of them are clearly labeled. This edge is opposite, no label. This edge is opposite. And I see a 6-inch width for prism B, but we just saw that these two share this same edge right here, and it has to be the same because it's opposite. So 6 inches is the width right here. The height would be this edge, which is not labeled, with its opposite edge, which is not labeled, with its opposite edge, which I see a 4 for the bottom. Sorry, I just got on the wrong one. But wait a minute. Prism A, this is the height, not labeled. This is the height, not labeled. This is the height. And I even drew a little stop right here and show you that 4 inches for the bottom prism, 4 inches for the top prism. So they have the same height as well. All right, let's get back to prism A. I just found the length 5, the width 6. Remember, it shared it with prism B, and the height 4. So when I multiplied, I went ahead and did length times the width to get 30 times the height of 4, 120 cubic inches for the prism on the top. It's a little bit smaller, so it should have a little less volume. Let's check. Prism B, I found that the length was 6 inches across. I can see that very clearly. It's this edge. The width we talked about is 6 inches. The height we talked about is 4 inches. 6 times 4 is 24. Did a little work. 6 times 24 is 144. You guys had your calculator. That makes sense. The one on the top is a little smaller than the one on the bottom. So prism A should be smaller than B in volume. Then I add these two volumes together to get the combined volume of 264 cubic inches for the whole rectangular prism shape. Or not, sorry, it's not. It's a solid. 2 rectangular prisms make this solid. It's not a rectangular prism in and of itself. So with going over this test, that should help you. You need to take that paper, your graph paper that's headed for your topic 11 assessment on volume. You need to put it back in your binder behind math test. We keep those there. You should have your work for your first test as well. All right, boys and girls, you have a quick video on multiplying and dividing using the standard algorithms, and then you have 10 math problems to do on graph paper in your neatest writing, keeping your work in the boxes. So I hope you have a great day. Tomorrow we start topic 14, working with coordinates, ordered pairs on the coordinate plane. So I will see you tomorrow when I introduce the concept with my video. Don't forget, Fridays I have video conferencing if you need help with any skills, 8:45 to 10:45. It's really crowded. I would say around 8:45 to 9:15. From about 9:15 to 10:45, you could drop in anytime during that period, and you may be the only one because it starts to filter out, and I can work one-on-one a little better during those times. All right, use your Google Meet link. It's in your Google Services icon in your ClassLink locker. Use the Google Meet code PACEL Math all lowercase, no spaces, and you can join me if you want to work on any of your weekly review problems this week. All right, have a great day.